Hi, I'm Katie Hunt.
And I'm Chuck Jones.
And we're going to show you the Just for the Sport of It experiment now. As you get started, this is where you need to engage the audience. To introduce this experiment, you may want to ask the audience a question and even ask for a show of hands. Chuck, why don't you show us how it's done?
Sure, Katie. You might want to ask the audience how many people have played baseball or softball, or how many people have been to a baseball game.
Or, have you heard the sound that the bat makes when it contacts the ball? It's important to engage the audience before you get started with the actual experiment. And do have some fun with this. Let's start with safety. Safety glasses are a must. These are common items we use at home, but all items should be handled safely. Although the items being used in the experiment are not harmful, they should be handled with care. Don't leave the bats and balls on the ground because you don't want to create a tripping hazard. The Just for the Sport of It kit will include the following materials: safety glasses, 2 to 3 pairs, one for you and the others for your student assistants, 3 meter sticks, 2 balls, 1 baseball and 1 golf ball. Please clean and save all reusable materials for your next demonstration.
Materials which you, the scientist, will need to provide: 1 baseball bat, either wood or aluminum, 2 textbooks, and either masking or duct tape. It is best if the tape is a different color than the bat. So now we're ready to start the experiment. In this case, you also need a student volunteer from the audience. We have Katie. Have you ever played baseball?
I have.
You're the perfect volunteer. The baseball bat is marked off so that you can measure different areas. A dark tape is good for light bats, and masking tape can be used on metal bats. Most of the students will be used to metal bats because of Little League and softball rules using metal bats. The first part of this experiment is to sense where the sweet spot might be. The sweet spot is that point at which there's no vibration transmitted down the handle, but rather it's transmitted into the ball as you're hitting it. There are 2 ways of doing this. One is to take a hammer on a metal bat and lightly tap it.
Could I have safety glasses?
Here are your safety glasses.
Thank you.
Safety first.
Yes.
So this, if you listen for the sound, you hear a higher pitch sound in the sweet zone. The other way of doing it is to sense the vibration. If the student holds the bat very tightly, takes a golf ball and drops it and catches it, they can sense the vibration down in their hand.
Vibration on that one. A little bit there. A lot there. Let's try this again. I don't feel vibration there. More there.
Okay. So where would you sense?
Hard to decide between these two. Maybe in the middle.
Okay. So that is another way of determining the sweet spot. Finally, what one can do is to actually use the golf ball and make a measurement on the sweet spot. In this case, the student would hold it down tightly on the book. You would put together 2 meter sticks into a V shape with masking tape. Using the measurements that are on the meter stick and resting the meter stick V on your shoulder, you would drop the ball from a consistent place and have the student measure how far up it bounces when it hits the bat with each zone.
21. 26 and a half. 29. 27.
So, in which case did we get the highest bounce?
I think it was here.
So that was where we also measured the sweet spot with the vibrations in the ball. And in this manner, you can learn about the effect the bat has on hitting the ball in the correct region to get the maximum distance on hitting the ball. So now that you've seen this experiment done and you're finished, you can use the discussion questions at the end to interact with the students and engage those students in science.
And have fun.